Alright, to graph functions, what you need to be able to do here is understand again the XY part of it. Okay, so a couple things here. One, we don't always use F as the name of the function. We can use any letter. Okay, we don't even have to use the letters, but G is commonly used, H is commonly used, H, G, A, W. But anyway, when we're using function notation, just the big thing to remember is all of this is just Y. It's just a way to get Y when you're making your XY pairs. Okay, so if you want to plot points, you need to have X's and Y's. Okay, remember you need an X to go left and right. You need a Y to go up and down. So what this is telling us to do is, for X, start with -2 and make your way in whole numbers, integers, up to +2. And these are the things that are going to go in to come up with our Y, okay, which is the same thing as g of x. Alright, now how do I get the Y coordinate? I do what the G function does. It doubles the input and adds 4. So I'm going to double the input of -2, and I'm going to add 4. Well, when I double -2, I get -4, and then when I add 4, I get 0. So when x is -2, the point that I plot is -2, 0. That's what I get for the Y coordinate. Alright, so -2, 0 would be right there. Okay, when I plug in -1 into what the functions commands tell me to do, -1 times 2 is -2 plus 4 is +2. So -1, 2. So -1, 2. Excuse me. Alright, when 0 goes in, 2 times 0 is 0, plus 4 is 4. So the point to plot would be 0, 4. 0, 4. Alright, when 1 goes in, 2 times 1 is 2, plus 4 is 6. So the point that I plot is 1 for x, 6 for y. Alright, when I do this stuff to those particular x's, these are the y's that I'm getting. Okay, y is g of x. Alright, 2 times 2 is 4, plus 4 more is 8. So 1, 6, 2, 8. And you can see every time I go 1 to the right, I go up 2 more. 1 to the right, up 2 more. 1 to the right, up 2 more. And if you remember anything about graphing from high school, if you've done this before, y equals mx plus b, m is the slope, rise 2, run 1. So rise 2, up 2, run 1, rise 2, run 1, rise 2, run 1. Alright, this is the y-intercept. If you remember, y equals mx plus b. So you see right there 4 is where we're crossing. So what we end up with here is a line, and that line is formed by connecting all these dots together. And this is what a graph is. It's just connecting a bunch of ordered pairs or points that you get. Okay, it's just when you have a function, you get one y for each x that you plot. Alright, so your function should never overlap like sideways. Okay, it can overlap vertically, like that, like a U shape, but it can't look like a C shape or a backwards C or something. Alright, but this is a straight line. This is like what we call a linear function. Alright, the vertical line test. Let me move this in a little. So what the vertical line test says is any vertical line intersects a graph in more than one point, and the graph does not define y as a function of x. So if I take a vertical line and at any point on the graph we hit the graph, the blue part of the graph, more than once, then in that case y is not a function of x. Okay, But if we can take a graph, alright, now notice this one's got arrows on the ends. That means that the graph continues in that pattern forever. So if I take this graph, this is a line, and I take a vertical line and I pan left to right, it never hits the graph more than once at any point. It only hits it at only intersects it once all the way from left to right. So in that case, y is a function of x. That does define y as a function of x. Now if you remember, a function is just a relation, which is a set of ordered pairs where one x is not paired with more than one y. And if you think about it here, this is the x. Okay, there's an x value. And it's paired with this y. And it's paired with this y. So we have up here that x and one y. I'm going to put y with a little 1 subscript. And then over here we have that same x with a different y, like y number 2. So it go back to the very, very first definition of a function that we had way back at the beginning. And we had an x coordinate with more than one y coordinate, which is exactly the same thing that we have now, that we're seeing now on this thing that is not a function. Okay, now go to the other two just to verify this is okay. If I pan left to right, I'll never hit the graph more than once. So that is a function. And on this very last one, you can see as soon as we get past the y-axis on the right side, we hit more than once everywhere. So that's not a function. Alright, and that's the vertical line test. Okay, just a vertical line passes through a function and never hits it more than once. Then we say it passes the vertical line test and it is a function. But if at any point a vertical line hits a graph more than once, we say the vertical line test fails and that graph is not the graph of a function, or at least y is not a function of x. Alright, domain and range from a graph. This is very similar to what we just did here. But if I want to come up with the domain of the function, I'm thinking of kind of like the vertical line test. Alright, so think of a vertical line panning left to right. Alright, starting on the left side of your graph and panning left to right. And where is the very first place that we hit the function? Right there. So the very first time we hit the function, that number that corresponds to where we first hit the function is where the domain starts. So I'm going to write domain. So -2 is where we start. Now, we keep going. We keep hitting the graph, we keep hitting the graph, keep hitting the graph, and then finally we stop hitting the graph right there. Alright, if I move any further, there's no more graph. So remember, domains are x coordinates. So 1, positive 1, is where this stops. Now, what do I do with those two numbers? In set builder notation, I do one thing. With interval notation, I do something different. But with set builder notation, I put an x in between these two. Okay, x is between -2 and 1. Alright, and if there's a closed dot, meaning it's filled in, I use less than or equal to. And then if it's an open dot like it is over here, I use just strictly less than. Alright, so in set builder notation, the way we finish this up, because set means we're going to have set brackets. But we put this little x out in front and then a vertical line. Alright, and the way this is read the set of all x's such that, this little vertical bar is read such that -2 is less than or equal to x and x is less than 1. Okay, and it means -2 is part of this domain. Positive 1 is not part of the domain. Alright, now, interval notation a lot easier. Interval notation, again, we're panning left to right. we first hit at -2. So again, we write domain colon -2, and again we keep panning and we hit the graph all the way until we get to 1, and then we stop pinning the graph. So at 1 we stop pinning the graph, so we write 1. Okay, now for interval notation we put a comma between these two numbers. So we're saying it starts here, it stops here. And then if it's a closed dot, instead of the less than or equal to symbol, we use a bracket. And we call that a closed bracket. And then for the open dot, we put a parentheses. So the interval starts with a closed dot, so we use a closed bracket facing inward. Then the number where it starts, comma, the number where it stops, and then because it stops with an open dot, we use a parentheses. Okay, now hypothetically, had that been closed, then this would be underlined, and this would be a bracket. Okay, if that had been open instead of closed, this would not be underlined, it'd just be strictly less than, and this would be a parentheses. Alright, now let's switch things up for the range. Alright, now let's do the range. For the range, instead of a vertical line, we envision a horizontal line. And the horizontal line would be starting at the bottom of the graph rather than the left side of the graph. The reason why we do that is the left side of the graph is where the negative x's are. Right? The bottom of the graph is where the negative y's are. So we start with the negatives always, and we make our way towards the positives. And we ask, alright, where do we hit the graph? So we're not hitting the graph, we're not hitting the graph, we're not hitting the graph. And then finally we start hitting the graph at 1. Okay? So we start hitting the graph at 1 for the y's. And then we keep going, even though we're not hitting the graph on the right side anymore at 2. We still are on the left. Right? We're still hitting graph. If I keep moving up, I'm still hitting the graph on the left, still hitting the graph on the left, and finally I stop hitting the graph at 5. If I go any higher than this, I'm no longer hitting any graph. So we have a closed dot when y is 5. So we're going to say we stop at 5. Right now, this, even though there's no dot there, right, we're going to use a closed dot because we don't have an open dot there to say that 1 is actually not a part of it. There's not a hole in the graph here or something. So we are going to use a less than or equal to down here, even though there's not a closed dot. If there's not an open dot, we're just going to assume that low point on the graph is included. Okay? Now, for range, we're not dealing with x's anymore, we're dealing with y's. So instead of x such that with the bar, we're going to say y such that with the bar. Okay, and then the last thing to fill in is this last order symbol. Up here, this is a closed dot at 5, that highest point. So again, we would use the less than or equal to. Okay, that had been open, then we would just do strictly less than. Alright, for the range and interval notation, again, as we started from the bottom of the graph and made our way up, we didn't hit anything on the graph until we got to 1. So again, we would start with a 1. And when we make our way up, we don't hit anything until, we keep hitting graph, all the way through until we get to 5. And then we don't hit anything above 5. So 5 is where we stop. And then again, it's closed and closed. So closed means we have a bracket. It's closed at the highest number, the biggest y value. So we have a bracket on the other end as well. Okay, so interval notation, the nice thing about it is just the simplicity. Where does it stop? Where does the graph start, in the y direction or in the x direction? Where does it stop, in the y and x direction? But the downside is you can't distinguish one from the other. So you would have to label it domain and range to know which one is which. Alright, technically with set builder notation, you know which is domain and range by what variable you use. X, domain, Y, range. So we wouldn't technically have to have this to label it. It's kind of standard too, but it's a requirement for when you use interval notation. Okay, you will need to be able to label it. Final exam is paper, so it's not electronic, and you will need to be able to distinguish these two. Alright, let's try a couple more of these and see how we do with them. Alright, set builder notation. Again, if I envision a vertical line going left to right, I start hitting the graph at -3. So I'm going to say it's the set of all x's such that I start at -3, so -3 is less than, alright, open dot, so I'm going to leave it just strictly less than x, and then I keep going all the way until I get to 2. That's the last x value where I hit the graph, and it's closed, so I need less than or equal to 2 this time. Alright, in set builder notation, I'm going to just put D for domain. -3 is where we start on the x-axis. 2 is where we stop on the x-axis. Alright, open dot means parentheses. Closed dot means bracket. So there's what the domain would look like. Now switching to range. Alright, the range or the y value, so we're starting at the bottom of the screen. So I don't hit anything until I get past the x-axis, and then right there at 1 is the first time I hit graph. Remember, I'm looking at a horizontal line when I do range. So if I grab this horizontal line from the last one, just to remind you what I'm doing here, I'm going from the bottom of the graph up until I hit graph, and I don't hit graph until right there. So the very first y, I'm on the y-axis. The very first time I hit the graph is when the y-coordinate is 1. So once again, it's 1. Alright, it's an open dot, so strictly less than y, less than or equal to. If I move this thing up, I hit y values, I hit the graph until the y value is 2. So I don't hit the graph very long in the y direction. Alright, and this time it's a closed dot, so it's underlined. Alright, so y such that y is between 1 and 2, 2 included, 1 not included. Okay. Range, I would just use R. 1 is where we start, so open dot at 1, so parentheses, and then 2 is where we stopped, closed dot at 2, so a bracket. Now what if the graph doesn't start and stop? What if it has an arrow in one direction? Well, think about the vertical line panning left to right. So remember, we come up with the first number when we do these domains by envisioning a vertical line panning from left to right. Well, because of that arrow, it means this function is literally going to keep going forever and ever and ever and ever and ever in this direction. Okay, it literally is going to keep growing off the screen. So no matter how far left I go with this vertical line, I'm going to keep hitting the graph. So it's just never going to have a lowest x coordinate. That's what we're doing here. We're listing the x coordinates that are on this graph. But because of the arrow, it's just going to keep going forever and ever and ever and ever and ever. So what we have to understand here is that there is no lowest x coordinate, and we have a symbol for that. And that symbol is set of all x such that is a negative infinity that we use for interval notation. Now for set builder notation, when negative infinity is the lowest x, then we just take that upper number. 4 is the biggest number, and we say x is smaller than 4. Okay, in this case it's less than or equal to, because it's a solid dot. So the set of all x is such that x is less than or equal to 4. Okay, so if the lower number is negative infinity, in set builder notation we don't have to write it because it's understood. If we wrote, for instance, if we wrote negative infinity is less than x is less than or equal to 4. Right, this part is redundant. It's obviously negative infinity is less than any number. So we don't have to write this part. So this part right here is just omitted. And because it's omitted, what are we left with? We're left with just x is less than or equal to 4. Okay, so that's all we have to write when we write the domain here, when we have that one direction. Alright, in interval notation, that's what I was saying when I was trying to get to. For interval notation, you have two numbers, a lower number and an upper number. If it keeps going in one direction, you have to write negative infinity or positive infinity if it keeps going in the other direction. So negative infinity, it stops at 4. Alright, 4 is a closed dot, so it's a bracket. We don't have an open dot over here on the left side where the negative infinity is, but we still use a parentheses always with infinity or negative infinity. Always use a parentheses. Alright, moving to the range. So once again, we're going to take our vertical line here and we're going to rotate it 90 degrees, make it horizontal. And we're going to pan it from bottom to top rather than left to right. So again, where do we start hitting the graph? We start hitting the graph when y, not x, when y is 0. So for range, the set of all y's such that 0 is our smallest y, but once again, just like before, it keeps going up and up and up and up, and it goes off the screen, but remember these lines that we're using extend forever in both directions. So I'll always be able to move the y's up because I'll always be able to extend this line forever and ever and ever and ever and ever. It's always going to keep growing. It's growing really slow, but it always is going to keep growing vertically. Okay, so there is no highest y, so we just write y is bigger than or equal to, because it's closed, the lowest y. Right, the lowest y here again is 0. So every y coordinate bigger than 0 is included, like for instance right there, that point, like negative 2.5, 2.5. Okay, there is the y coordinate there is positive 2.5. Any y coordinate bigger than 0 is eventually going to be a part of this graph. Okay, eventually we're going to get up to like 100 for the y's. It's going to be way, way, way over here off screen, but eventually we are going to have that y coordinate. So all the y values bigger than or equal to 0 are on this graph. That's what we're saying here. Now interval notation for the range, again, for interval notation, you always start with the smallest number. The smallest number here for the y's is 0. Right? 0 is included right here, and then it grows as we make our way up. We have to go further to the left, but it is going to hit every y coordinate on the y-axis at some point. So that means 0 is the smallest, and it's included. It's got a closed dot, so we use a bracket. And then infinity, positive infinity, is the biggest number. Okay, so notice every time we've ever done interval notation, it's always smaller number, bigger number, smaller number, bigger number, all the way up when we do interval notation. Smaller, larger, smaller, larger. Okay, so keep that in mind. It's always going to be that way when we use interval notation. All right, these last couple of examples, it's going to have us do the same thing, but in addition, we want to use function notation to find the indicator values. So let's practice first our domain and range, just like we've been doing, and then we'll get into the new part. All right, so this is the set of all x's such that vertical line, we got arrows going all the way to the left, arrows going all the way to the right. So if I had a vertical line, it's always going to hit graph here. All right, so if I take this thing pan left to right, again, there's nowhere on the x-axis. Again, think about moving along the x-axis and that line's going up and down from the x-axis. There's nowhere on the x-axis where this vertical line coming up or down is not going to hit the graph. So it's everything. So the way we would write it is x such that x is a real number is what we would say. Alright, but the symbol, we have a symbol for that, and it's this little R, double back R is what I call it, but it means all real numbers, or just all reals. Okay, so any real number has a graph, either on the x-axis or in this case above it. Okay, in interval notation, the way we write all real numbers is we start with negative infinity and we go all the way to positive infinity. Alright, now, what about range? Well, the range is different here. Again, take my vertical line and rotate it to become horizontal. And start from the bottom and make your way up. We don't hit any graph. It's not all real numbers. We don't hit any graph, we don't hit any graph, and finally we do hit a graph at 1 on the x-axis or y-axis. So we start at 1 and we go up, and again, because of the arrows, it means we're always going to be able to keep rising. So we say y is greater than or equal to 1. Alright, range in interval notation, we would write bracket 1, that's the smallest y value, comma, infinity. It keeps on going. As I move up on the y-axis, there's always somewhere, either left or right, or both in this case, where I'm going to hit the graph forever because of the arrows. Alright, now this last part. F of negative 1. What that means is find negative 1 on the x-axis. Remember, f of x notation. X is what's in the parentheses. So x is the numbers on the horizontal axis. So it's saying find negative 1 on the horizontal axis and go up or down until you hit the graph. And then where do you hit the graph? I hit the graph at 2. So f of negative 1 is 2. Alright, and then find 3. Here's 3. Go up or down until you hit the graph. I go up until I hit the graph right here. And what y value are you at? 4. So f of 3 equals 4. Remember, what all this means is the y coordinate when the x coordinate's negative 1. The y coordinate when the x coordinate's negative 1 is 2. Alright, the y coordinate when the x coordinate's 3 is 4. Okay, that's all that means. Alright, last example in your 1.2 notes. So, set builder notation for domain, set of all x such that left to right, the first x I hit is negative 1. And then if I keep moving to the right, I'm always going to keep hitting x's. Okay, because this arrow means I'm going to keep going. I'll be able to always hit an x. So I would say x is greater than or equal to, because it's a closed dot. Okay, if it were open, I wouldn't underline it. But it's closed, so I underline it. Negative 1. Alright, close the set bracket. The domain in interval notation, where does the domain start? The smallest number is negative 1. It's closed, so I put a bracket. And it keeps on going to the right. So again, I use an infinity symbol and a parentheses. Alright, range is y values. So the set of all y's such that, again, if I start at the bottom and make my way up, I don't hit the graph until the x-axis. So that means the y coordinates here, this is 0, not negative 1, this is 0. So 0, and then again, because of the arrow right here, I'm going to be able to always hit the graph. The higher and higher I get on the y-axis. So y is greater than or equal to 0. Alright, interval notation for range. The smallest y coordinate again is 0, so that's the lower number, so that goes first. And again, the upper number is also infinity, because it always I can always go higher, because the graph's always going to keep going. All right, and then f of 3, here's 3. I go up until I hit the graph. I hit it right there at 2. So f of 3, the y coordinate when the x coordinate is 3, is 2. All right, if you have any questions of those, try your homework out. If you have any questions, just send me an Ask My Instructor link. I'll help you out with the one you have.